In this video, we are going to look at the reactions of copper. These will include reactions with air, water, the halogens, acids, and its displacement reactions. The most common reaction of copper is the formation of verdigris, vert being the French word for green, on buildings roofed with copper. This happens slowly over time as the copper is oxidized by the oxygen in the air. Then, in damp conditions, this slowly reacts to form basic copper carbonate, the pale green covering you may have seen on rooftops or even the Statue of Liberty. Why don't you try leaving a copper coin or object partly in water? You too will see the same pale green covering form. Failing this, if you have the opportunity, in a science lab, you could heat copper until it's red hot. Think about what might form. Now see if you can write an equation to show this. Pause the video and continue when you're ready to check your answer. On heating copper with oxygen, the result is the formation of copper-2 oxide, shown by this equation. This may seem useless, but you can use this reaction to measure the percentage of oxygen in the air. This is achieved by passing a known volume of air over hot copper and measuring a decrease in volume as the oxygen reacts with it. Now, what about the reaction of copper with water? Think about copper's reactivity with oxygen and its position in the reactivity series. Pause and continue when you're ready. An answer is that copper doesn't react at all with water, and so this is often why it's used for pipes. Similarly, this is the case why coins are also often made out of copper. Next, if you react copper with an excess of a halogen, that's fluorine, chlorine, or bromine, it will produce a copper halide. These halides have different colours, as shown by the equations on your screen. The next reaction we're going to consider is how copper reacts with some dilute and concentrated acids. There are a couple of possibilities. They include sulfuric acid and nitric acid, but copper doesn't react with hydrochloric acid. Copper will produce nitrogen oxide gas in dilute nitric acid, as shown by this equation, whereas in concentrated nitric acid, nitrogen dioxide is produced, as shown by this equation. However, you should be warned that nitrogen dioxide is toxic. Finally, what about when copper reacts with concentrated sulfuric acid? Can you predict what will be produced? Pause the video, try and write an equation, and continue when ready. The correct answer is that sulfur dioxide is formed in the following reaction. The sulfur dioxide produced in this reaction is toxic, so care must be taken. The last idea we're going to consider is why copper is often obtained in displacement reactions. You may have guessed it's due to its low reactivity. For example, any dissolved copper salt, say a copper sulfate solution, will be displaced by an addition of any metal that is above copper in the reactivity series. So, if you were to add magnesium, what do you think would be formed? Pause the video, write a chemical equation, and check the answer when ready. The answer is shown here.